Good morning. Welcome to day 3. And what we're going to look at now is we're going to think about how to do a little bit of specialized things in dimensional analysis. There's a couple things that we haven't addressed yet. And first of all, don't write this down, but if I were to ask you to convert 50, let's say 50 millimeters to liters, would you be able to do that? No, because that's going from distance to volume. That doesn't really make sense for us. But there is another conversion that might at first glance look kind of goofy, but it does make sense. We were going to have, and you don't really have a place on your notes for this, you just have to add it up to the top. But we want to be able to convert between cubic centimeters and milliliters. Both of those units measure what? Volume. So both of those would be units that measure volume. This we typically use when measuring some sort of solid, and milliliters would be used when measuring a liquid, typically. So you do have to memorize this. Put your little stars by it. Make sure you know this, but it's a really, really easy one. Anybody know it? A cubic centimeter is what? A milliliter. It's exactly the same thing. What you're going to see is that mathematically in dimensional analysis it doesn't change things, but it's important to go ahead and show that conversion in there because it's going to change the units as you go through it. Okay, so that is our new thing that we're learning. Also, we're going to look at how we go about using cubic conversions. So if we're talking about volume, you've got a length cubed, how are you going to do those conversions in your problem? And when doing so, here's a little reminder that not only do you have to cube the unit, you're going to also have to cube the number. And that'll make sense when we go through these. So the first question, it says that we want to convert to cubic meters if we're starting off with 0.0448 cubic meters. Well, based on what we learned yesterday, we know that we can really easily get rid of meters and go to millimeters. We have learned that conversion. Which one's bigger? Meter. So one of these big guys, there are 1,000 of these little guys. But now if we stopped right there, this meter cancels out, and one of these meters cancel out. So we would have our answer as meters squared times millimeters, and that's not what we want. So what do you think we have to do? Do it again. Okay, so we're going to get rid of another one of these meters and go to millimeters. Again, it's the same conversion factor. 1 meter is 1,000 millimeters. So now we've gotten rid of another one of those meters. And if we stopped right now, we would have meters times squared millimeters. Not good enough. So last little step, we are going to get rid of that meter and go to millimeters, 1 per 1,000. And now we have gotten rid of our meters entirely. We have left millimeters, millimeters times millimeters, which is cubic millimeters. That's exactly what we wanted. So we know that we set it up right. You can plug all this into your calculator, but also this is a lengthy way of showing my work. I want to show you another way that you could do this that you're probably going to prefer I just wanted to make sure that you guys understood why we're doing this. But from now on, when you write this down, chances are you'll just want to write something like this. That you're starting off with that value. I'm not putting any parentheses or anything around that. You're starting off with that value. You want to get rid of your cubic, you want to get rid of your cubic meters and go to cubic millimeters. Now notice what we had to do in this. Not only did we cube the unit, which is what we mentioned here, but that number of our conversion, here's our conversion, this number is also cubed. So another way that you can show your work is by showing that with parentheses, that is cubed. Okay? So that's an easier way of doing it, especially if you have quite a few things going on in your problem. So the common mistake is that people get so caught up in trying to remember that they're cubing this that they come back here and want to cube this number. Notice that this number is the way it is. It's just 0.0448. You do not cube that initial value. You just cube this one right here. So when you plug it in, have you been hearing calculators? So anybody get an answer? Okay, so million, I have to count my zeros, and I can count 44 million would be what it is, or let's just write this down. If you were to get it in your calculator, you should have 5 zeros. When you convert that to scientific notation, personally I would look at that and probably throw it into scientific notation, which would be 4.48 times 10 to the what? 7. And then we always show our units. Oops, forgot my 10. Times 10 to the 7. Okay, yeah. Absolutely. So the question is, can you report it like that? And the answer is yes. And, you know, occasionally on a quiz, I might, especially this first unit, we might ask, hey, show it to us in scientific notation just to make sure that you guys know what to do. But however you want to report it, it's fine. And then let me go back real quickly to this beginning number. We've got 3 significant figures, 3 sig figs, 3 sig figs. Make sure you don't throw a decimal point in there because that would throw it. Okay, moving on to our next one. Here we see that we have an automobile engine, and it has an internal engine volume of 286 cubic inches. We want to figure out what that is in liters, and that's valid because both of those are units of volume. So we want to go from cubic inches to liters. So going to liters, starting off with cubic inches. Okay, couple different ways you can approach this. You were given some conversion factors yesterday on your handout. It was on your homework as well. Those are some English metric conversions that you do not have to memorize. But what's one of them? Do you remember one that might be helpful here? Awesome. So going from inches to centimeters is what I'm hearing. So we want to get rid of the inches and go to centimeters, and without even looking, he even knew that it was 1 inch equals 2.54 centimeters. You do not have to memorize that, but you should be able to look it up and know to use it. So what do I need to do to my inch down here? Cube it. Not that it really matters. I also need to cube that number, that 1. What do I need to do to my centimeters? Cube it. And what about my 2.54? Cube it. So now at this point, we have it to where we have it in cubic centimeters. We just learned a conversion factor that's going to come in handy for us. Cubic centimeters, what can we go to? Milliliters. And we know, hey, it's an easy one. It's just a 1-to-1 conversion. But by doing that, that got us from the cubic units over to the liters type of thing. So some sort of prefix with our liters. So now we've got it as milliliters. I'm going to get rid of my milliliters and go directly to liters. What number goes up top? 1, bottom? And I cube those? No, that was a trick question. There's no cubing going on. So we've got those as milliliters and liters, so all is good. So that's how you set that up. You plug it in. And big long number in your calculator. What does it start with? 4. Yeah, 4.686700304. Just to show you that you're going to get these big numbers in your calculator, you need to remind yourself, I need to take that and report it as the correct number of sig figs, which you look back here and you see it's going to be 3, so therefore it becomes 4.6 what? 9. So you round it up, and then that's liters. Okay, that's really all there is to that additional stuff on dimensional analysis. Hopefully that wasn't a big jump for you guys. Now we're going to do a couple problems that have percents in them, just some percent calculations. And I think you guys already know this, but whenever you see percent, you should be thinking to yourself, part over whole. That's the formula. Percent equals part divided by whole, and then because it's percent, you have to multiply it times 100. Well, if you're solving for percent, that's pretty straightforward. If you're solving for either the part or the whole, the easiest thing to do is go ahead, let's write this down. When given percent, divide each side by 100. It's the easiest way to deal with the math in this. So if you divide this side by 100, well, you just got rid of all that. And then when you divide this side by 100, you have now decimalized your percent. So it becomes a decimal. So that's going to be what you're going to want to do in that area. So the first one, it says how many grams of salt and how many grams of water. So those are our two things that we're throwing in there. Would you use to prepare 85 grams of a solution that is 12% salt? Which one of those underlined words is the whole in this solution? This is that whole that we're looking for. These are each parts. So when we think about part divided by whole, that's what you're thinking about. You need to read carefully. So when we set this up, since we're given percent, I'm going to go ahead, divide it by 100. I'm just going to decimalize that, meaning it becomes 0.12. It's part over whole. What are you going to put in for part? X. That's all you got to do in this case. We don't know what the part is. That's what we're looking for. How many grams of salt? That's going to be a part that we're looking for. So how many grams of salt is, and how many grams of water? Okay, so we're going to have to do that as well. So I'm going to start with the salt. I'll make myself a note. Okay, because we're looking for both of them. And our solution is going to be, the mass of our solution is 85 grams. And again, I just want to remind us that this is part and this is whole. So now it just becomes a simple little math problem. You're solving for x. And x in this case, we're going to say x, which is salt, is going to be what? 10 grams. I like it. When you say 10 grams, what do you mean? How would you write that? Okay, yeah, I'm going to put a lowercase in there. How many sig figs do I need to report this to? 2. In my calculator, I think it gives 10.2. How are you going to report this? 10 point. Easiest thing to do. So that is my two significant figures showing that it's grams. I know that looks a little goofy because you guys don't typically do that when you write these numbers. But that would be you could also put it into scientific notation. You could use the bar over the 0 that we talked about yesterday. So a couple different options for you. Okay, so that is for maybe 10 grams of salt, if we want to say that. And then a couple different ways we could go through figuring out the water. We could go through this again with water as our x. Or what else do you want to do? Just subtract it. That's the easiest thing. So we know we have our 85 grams, which is that entire solution, minus our 10 grams, which is your salt. In fact, think about your rules for addition and subtraction. How are you going to round this? You're thinking about how many digits are after the decimal. There's no digits, so it is just 75 grams of water. All right, one more that we have And here it says that we have a mineral that has a copper content of 25.5%. In a certain experiment, 561 grams of copper were recovered from a pure sample of the mineral. What was the mass of the sample? So here, since it's the mass of the sample, what are we looking for, part or whole? Whole. So again, in this situation, we happen to be given percent. I'm going to decimalize that, divide it by 100, and just make it 0.255. That way I don't have to worry about multiplying by 100 on the other side. Do I know the part? Yes, it's that 561 grams. I'm going to even write grams of copper. There's our symbol. Not that you need to know that yet. That'll be coming up soon. And then what we don't know is the mass of the, we're looking for the mass of the entire sample, the total, or the whole. So in this case, we're just going through and doing the math again, and we're going to say that the mass of the whole sample is, in your calculator it gives you, okay, so there's our calculator answer. Now, based on significant figures and in a problem like this, yesterday when we did dimensional analysis, we always based our sig figs on that very first entry, what we wrote down, what was given. You're really given two things here. So you're going to base it on both of those. They happen to be the same as far as sig figs, so you're going to round it to 3 sig figs. This is that tricky one. What do you want to do? A bar. Okay, so let's do that. That's easy enough. We have just made that 0 significant. And then yesterday we also talked about how this is another way that you could have reported it. And then we want to make sure that we say it's grams of the whole entire sample. Okay, and that is all we have. So nice job.